So welcome to the latest Reigate College Maths Year 2 Statistics video. These are on normal distribution and this one is on the inverse normal distribution. So we've seen how using the normal distribution on the calculator tells us a probability for a value of our variable, which we normally write as x. What we're going to do this time is we're going to go back the other way and say, if we've got a probability, can we work out what value of our variable x that probability applies to? So the probabilities are represented by the area under the normal curve, and here are our values here. In this case it's got z, it's the standard normal distribution, but often we'll have x here. I'm going to show you how to use the calculator to find these probabilities. You can also find a table in the formula book, but it's much more straightforward to use the calculator. So what we'll do is we'll have a look at these examples here. We've got a random variable x, its mean is 5, its standard deviation is 0.1. Remember that we write the variance here, so it's 0.1 squared. We want to find the value of a, which gives us a probability of 0.3. So what we're going to do is we're going to start off just by drawing a little sketch here. So here's our normal distribution. Here's our mean in the middle. We know that's 5. And what we want to do is we want to find this area here. So we're going to say that's 0.3, and this value is a. So let's go and have a look at the calculator. What we're going to do is we're going to say menu, and then we're going to choose the distribution, function 7, and this time we're going to choose inverse norm. We're going to say that we want our area to be 0.3, 0.3, there we are. We need to put in our standard deviation, which was 0.1, so 0.1, and we need to put in our mean of 5, and then we just press equals, and that gives us a value for our value a here of 4.9476. A equals 4.9476. We wanted to do decimal places, so we're going to write a equals 4.952 decimal places. Okay, so that's A. Let's have a look at B. So B, let's sketch it out again. You are much less likely to make mistakes if you sketch these out in advance before you go to the calculator. So let's sketch this out again. This time, we've still got 5 there. This time we want the probability that x is greater than a is 0.1. So we're over this side of our graph. We want that to be 0.1. Now the calculator only finds the areas to the left of the value. So this time our value a is 0.1. We're going to say that the probability that x is greater than a equals 0.1 is the same as the probability that x is less than a is 0.9. So it's actually that 0.9, area 0.9 that we're going to put in the calculator. So let's go back to our calculator again, and we're going to go area is 0.9, and that gives us a value of 5.128, so 5.138. decimal places. Right, so let's look at part C, which is a tiny bit more complicated. So C, we want the probability that x is greater than 4.95, but less than a to be 0.6. So let's sketch this again. So this time, so we've got still got 5 there. We've got 4.95 there. We've got a what do we want to be 0.6 a somewhere over here. Now we have already seen that we want the a to be here and the this to be 0.6. So we've already seen that the probability that x is greater than 4.95 is 0.3. We saw that in part A. So from part A, probability that x is greater than 4.95 is equal to 0.3. So the probability that x is less than a and greater than 4.95 equals 0.6 is equivalent to probability that x is less than a is equal to 0.9. So that is simply the question from part B. So from B, A is equal to 5.1. Now for part C, it says find the lower quartile and find the upper quartile and hence the IQR. So for D, what we're going to do is we're going to say the quartiles look like this. Let's sketch it again. There we go. Here's our 5. Here's Q1. Here's Q2. Now the quartiles mean that we've got 25% here, so 0.25. Same here. It might not look like it on my sketch, but it is just a sketch after all, 0.25. So, first of all, we're going to say for Q1, we want to look up area 0.25. So let's do that now. So we're going to go area 0.25 and we get a value of 4.93. So Q1 equals 4.93. Q2, well, we could look up area 0.75, or we could say to ourselves, well, this is symmetrical, so Q2 must be the same distance above the mean and the median and the mode are all in the same place for a normal distribution. So Q2 must be the same distance above the mean as Q1 is below the mean. So Q2 we can straight away write down as this is 0.7 below the mean, so it's 0.7 above the mean. Q2 equals 5.07. So the IQR is equal to 5.07 minus 4.93, which is 0.1. We could do it to a greater level of accuracy than that, but we've been asked for 2 decimal places. Okay, so let's go on to question 2 over the page. So this says, use the percentage points table to find the value of z such that the probability of z is less than little z is equal to 0.025. So this is referring to z, the standardized normal distribution function. Let's just have a look, first of all, at how we're going to do this on the calculator, and then we'll look back at that table as well. So for A, on the calculator, we're going to say that we want, actually let's sketch it out again. So if we sketch it out, we're going to have, this is Z now, we're going to have a mean. Remember that the mean for the standardized normal distribution is 0. Let's just write down, sigma equals 1, and we want to find this value here so that this is 0.025. So we're going to look up an area of 1 minus that on calc area equals 0.975. Let's just go and look at that. So we need to put in area 0.975. We need to put in a standard deviation of 1. We need to put in a mean of 0. And there we are, we get 1.95996, or 1.96. So 1.96. We go and have a look at the table which you've got on the previous page. What we can do is we can say, if we look up a probability, we've got probabilities down here, 0.5, 0.4, and so on, continues in this column, and then we've got the value of z associated with them. So if we go down here, this is 0.1, getting smaller, 0.05, here's our 0.025, and there's our value of z, 1.9600. So that's what it means to use the percentage points table. Let's actually write that out to 0, 0. Let's now do question B. So part B, part 1. So we've got an examination board, assuming that their marks at maths A level can be modelled using a normal distribution with a mean of 70 and a standard deviation of 16. So we've got to say, why might a normal distribution model not be valid for modelling marks? So one thing to say is that this is a model, it's an approximation, and the normal distribution is a continuous distribution, whereas marks from an exam will be a discrete distribution. You can only get a whole number of marks. So we might say that normal dist is continuous, but marks follow discrete function, or distribution rather. Now that might be valid, but we do actually use the normal distribution function to approximate for large samples to a binomial distribution. So, and we'll see that later on. So that's possibly not an entirely reasonable criticism. What we can say though is that if we go 2 standard deviations above the mean, so 2 standard deviations above 70, so we're going to say mu plus 2 times sigma is equal to 70 plus 2 times 16, which is 104, and if sorry, it's 102, isn't it? Which is 102, and this suggests a percentage mark of greater than 100% is possible. Now, I don't think it's entirely clear that these are percentages, so maybe that's also not a reasonable criticism. Maybe the mark is out of 120 or something like that, or out of 110. So let's go on to part 2. We're going to say, assuming that the marks do follow a normal distribution and exactly 2.5% of the candidates will receive an A grade, what is the grade boundary for an A star? Well, for for 2.5% of candidates to get an A star, well, A star is going to be up at the top end. So this is the distribution that we've just sketched in part A. So we want our mark to be at 1.96 times the standard deviation above the mean. So we can say now that A star boundary is mu plus 1.96 times sigma, which is 70 plus 1.96 times 16, and that comes out to be 101.36. I'm not going to do that calculation on the calculator now. But what I also want to show you is that if we look up an area of 0.975 and we use this mean and the standard deviation of 16, we're going to get that 101.36. So we can either use the standardized value that we've got, or we can actually put it into the calculator using the mean and the standard deviation that we know. So let's go down here and put in standard deviation of 16 and put in a mean of 70, press equals, and there we are, there's our 101.36 that I was telling you about. So that finishes how we use the inverse normal distribution function, or the first section of it. We're going to go on in the next video to look at how we can use that in situations where we don't know the mean, and we don't know the standard deviation, or we don't know both, but we do know values of a variable and probabilities. We can find out that unknown mean and standard deviation. So that's it for now until we come back to that.